Hi, and a very warm welcome to this Areopa webinar. This is already the 99th Areopa webinar, almost the 100th. Didn't know that it was this number that we get. And in this case, Arthur van Vondervoort is together with Tobias talking about grabbing BC artifacts with Azure functions. I'm your host, Bert Verneek. Some housekeeping rules. Your mic is muted. You can post questions in the questions webinar, and I will pick those up. And we have agreed on at the end of the webinar, I will ask the questions. The webinar is also recorded, and all the recordings you can see on the YouTube channel of Areopa webinar, where we can see everything. And if you want to know what's coming up front, then there's also a newsletter that you can subscribe, and I would recommend that one so that you can see all our upcoming webinars. And what kind of webinars are they upcoming? The next one that is moved from the 25th of last year, Christian Lenz is talking about elastic leaderships applied for development teams. Then 2 weeks later, Tina starts how to be a prompt engineer. KB will be on the topic, don't be a messy AL developer. 2 weeks later, Søren, the PM of Microsoft, will talk about 45 tips in 45 minutes. And we are always looking for new speakers. You can suggest also topics for it, but if you want to be a speaker, just reach out to us and we will plan together with you a webinar. And the last slide is, before we can start and give over to Tobias and Arthur, is a thanks for the sponsor, for NAV. Thanks for all hosting this. And then Tobias, I'm giving you the presenter mode.
Great, thanks for the introduction. I hope the screen is now visible.
Yeah, screen is visible for me.
Perfect, thank you. So yeah, I'm a bit sad that we couldn't complete the full 100. We only made it to 99, but Christian will certainly also be a great 100 then in the next episode. Yeah, as Bert already mentioned, we will talk about how you can get your BC artifacts in your pipelines and maybe also in other places via an Azure function. And of course, we won't only show you the result, but also how it works. But to introduce ourselves even more than Bert already did, my name is Tobias Fenster. On the business side, I'm a managing director at 4PS by Hilti in Germany. In the community, I'm a Microsoft MVP, both for Azure and for business applications, and a regional director and also a Docker captain. And if you want to get in touch, you can find me on LinkedIn, on Blue Sky, and you can also find my blog and my podcast on tobiasfenster.io. Arthur, really happy that you're joining me today, but please introduce yourself for the audience as well.
Great. Thank you, Tobias. My name is Arthur van Vondervoort. Again, in the business side, for me, I'm in Belgium at a company at Verroy working, mostly on Business Central, but also some parts of the Dynamics stack around that. And in the community, maybe I'm a little bit known as also an enthusiast contributor to the Business Central Lintlocop as an open source project. And next to that, I'm also very enthusiastic about DevOps. So it's also an interest area of myself. Next to that, you can find me on LinkedIn or on Blue Skies. And also there, I'm posting a little bit what I found or what I update on.
Thanks a lot. So what are we going to talk about today? Why and how the service, the BCartifactURL-Proxy was built, how it actually runs on Azure. So a bit of a peek behind the scenes for the infrastructure for the deployment, and then the accompanying Azure DevOps extension, why and how that one was built. But first of all, why the BCartifactURL-Proxy? I guess that most of you in the audience probably are using Business Central containers in some way, shape, or form. And if you use a container, a Business Central container, you also know that you first need to build an image to get the container up and running. For those of you who are not using it, this is a way to create your own Business Central environment, not in the cloud, but locally on your laptop or on a VM or something like this. So this comes into play whenever you need a local environment or you need maybe an environment in a build pipeline, then a Business Central containers are relevant. But every time that you need a container or a container image, you also need the artifacts. And as you can see here in the second line, to get an artifact, you can use the get BCartifactURL PowerShell commandlet. And that needs parameters like the country, the version, the type, etc. And then you get a response that tells you, well, if you want to build a, in this case, 25 Germany sandbox container, then you need to use this URL. So this is basically the root problem that we wanted to solve or that we looked into. You need to get this artifact URL. This is typically done with the BC Container Helper PowerShell module, and it can take quite some time, to be honest. So depending on which kind of artifacts you want to have, especially for the sandbox artifacts, this can take 30 seconds, 40 seconds, maybe even sometimes a minute or more. And even if you have a solution where you're not using BC Container Helper or even not using container images, you still might want to have the artifacts. For example, the obvious one, building container images, but also if you want to just get something out of the artifacts because bug file of the demo Kronos company or the VS Code extension for the AL language, the V6 is also in the artifacts. So there might even be scenarios when the artifact URL can come in handy, even if you're not using containers. The problem that we faced is that if you run a pipeline and other things to fetch those artifacts, that's quite a waste of time and resources because you're doing it over and over again for your feature pull requests whenever that one is built, or for your development environments whenever a new one is created. And that is basically only taking a look at one company. But if you think about how often that happens across different Business Central partners and even customers who are using that, then you realize, okay, the artifact URLs are fetched quite a number of times, and a lot of time and resources are spent on doing that. Another aspect of it is that you might even have scenarios where you need an artifact URL, but you can't run PowerShell. For example, you could use the Azure Container Instance Service, which basically allows you to create a container instance somewhere in the cloud via the Azure portal, for example. If you want to do that for BC, you still need to have an artifact URL, but you don't have access to PowerShell in that scenario. So it could be easier to just use the BCartifactURL-Proxy in that case as well. So this is the why. We saw that grabbing artifacts is done very often. It's not the most efficient part of it. And we saw an opportunity to improve that by building a little proxy that helps to cache this, make it faster, make it work across different requests. But how is it built? The basic idea is that a request comes in, the parameters are validated, so we know that actually this is a valid request of the to the proxy. Then the BC Container Helper command is created, so you can see behind the scenes we're using BC Container Helper to get the URL. But then the important thing is the one in the lower row, basically on the right, that the cache is checked. So you can see that we are caching this to allow multiple requests to get the same answer without waiting for the result. If we find a valid entry in the cache, then we return it. If not, then we're still in the same place as before. We need to run the BC Container Helper command, wait for however long it takes to get the result, and then return it to whoever is calling the proxy. So the big difference really is the cache here, and that you don't necessarily need to have BC Container Helper in the place that is calling the proxy to get the artifact URL. To give you an idea of what this looks like, I want to show you a part of the sources. And for that, I will switch in the environment over here. You can see here the sources for the BCartifactURL-Proxy, and this is actually completely available on GitHub. So if you want to take a look for yourself after this session, if you want to understand how it works or even contribute to it and have ideas how it can be improved, you can find it. And we have the link, I think, on the last slide. So let's go into the code. And the really most interesting one is the get URL class here. Actually, it's not that complicated. You can see here after a couple of variables are defined. I'll also move this over here a bit. You can then see the actual trigger that gets triggered here and the route over here shows you that you can put in the type, so sandbox or on-prem. You can put in the country, Germany, Denmark, the Netherlands, whatever, and the version, and all of those can appear here. And we have a number of additional parameters, like, for example, you want to have only results after a specific date. Earlier, we had to provide a storage account. That's still possible for backward compatibility. You might have to accept the insider end user license agreement. And we even have something like the cache expiration here, but Arthur will share more about that in the later stage of it. Then we first of all create the response. So we let the caller know that we want to return something as a text. We will let you know which BC container helper version we're calling, because maybe there might be a change in that as well. And we will also let you know which BCartifactURL-Proxy version you're getting. Then we have the validation of the parameters down here. So you can see that we take a look whether something valid has been put in or not. And we can also do the do not check platform parameter for getting the URL. We also check the offset for the expiration. So when we check for the caching, as I mentioned, that can also have a specified time frame before which we don't accept cache entries. So you can make sure you only get something that's not older than a specific date. Then we create the actual BC container helper command that you can see here, the get BC artifact URL, and then all the potential parameters. And for you to understand what is actually happening behind the scenes, you will also get the command in a header. So if you take a look at the command that is run, you will also get the response here. Then we take a look at the cache. So we figure out if someone else has done the same request before. If yes, we let you know, okay, we got this from the cache. And we also let you know the timestamp of that cache entry. So you can also see from the response how old that entry potentially is. If not, we also let you know, no, this is not coming from the cache. We put it in the cache and you get the response. And then also there is a redirect thing. So if you want to redirect the request to the URL, then this is the default. If you only want to get the response where that URL is to later use it, you can set the do not redirect parameter to true. And of course, if an error is happening, then that would also get returned. So to show you how that actually works, let's just simply hit F5. With that, we're getting this to start. It's doing the typical .NET stuff, so it's restoring the project. And I hope this is quick. Yes, indeed, 2.5 seconds. Now it is starting. And now we're running locally the Azure function, because as we will see at a later stage, this is in the backend actually running in an Azure function. So also development has to happen there. To show you the result, we also have a test script that is part of the repository. There I have now defined it to call the local host, so the one that is running on my side. And then I can just call it. And this is now calling the function that we have just seen. You can see we're not adding any parameters here. So we're only telling it to not redirect. We're just getting the artifact URL as a response. So it's just using the defaults, which is the latest version. Can't remember what the country is, but we will see in a second. And it also is using Sandbox. So basically, as you can see here in the documentation, this is the command that we would expect. And as you can now also see from the timing, this is now running for a bit more than 30 seconds. This is an example of one of the requests that actually take a bit longer. You can see now here, okay, it took 40.5 seconds. And if I increase the size here a bit, you can also see, okay, the BC container helper version is not here. We can show you that globally, then you will see it. But the artifact URL-Proxy, we have the command that has been used, which is exactly the one that we expected. And we can see that it is not returned from the cache because I just now started the instance, so there is no cache. Also, you can see here the URL that has been returned. So this is the artifact URL that I could later use. And to show you that the caching actually works, if I send the exact same request again, now it's responding in 62 milliseconds. And I can see, yes, this is actually being returned from the cache. And I can see here the timestamp, so basically the age of the cache entry, which I could use to analyze in case I have some specific requirements on that one. Yeah, so this is basically the core of it. What we're also doing is behind the scenes that we're just using the PowerShell scripts from BC Container Helper. So you can see here on the left, we have the helper functions, which we need, and we have the get BCartifactURL-Proxy. You can see here we also put in a link to the sources because this is actually what Microsoft is providing as part of the BC Container Helper. This is not our script. But instead of installing it and getting the whole BC Container Helper, which by now is quite a large module, we're just using those two scripts, which we use as is. So they are not changed over here. Okay, so this should give you an idea of what this is all about. If we take a look at how development works, you maybe noticed I have been using a dev container using the standard Azure Function template. Dev container means that the development is actually done in a container. And I'll show you in a second how the configuration works, because this also makes it very easy for you to contribute if you're interested. On startup, it does what I just explained. It grabs the get BCartifactURL PS1 and the helper functions PS1. We will see that in the Docker file, put them in the right place, which is done in a configuration file. And then exactly as I did, I can just hit F5 and run it for testing. So how would you do that if you want to use the same, if you want to contribute something or just take a closer look? All you need to do is, sorry, I need to show the extension. So there is a dev container extension created by Microsoft. You can see here, and that one together with the Docker desktop allows you to run those dev containers. All you would need to do is go in here and say clone repository in container volume, an action of the dev containers group. And then you would put in Fenster, BCartifactURL-Proxy, ArtifactURL-Proxy, as you can see here. Click on it, it would clone the repository and start up the dev container. I don't want to do that because it would take like 2 or 3 minutes on my machine. For you, it might take even a bit longer if you've never done it before, because it would need to pull some base images, but at like 5 or at max 10 minutes, you should have a development environment ready to go. And then all you need to do is hit F5 like I did, and then you have a running version, hopefully that you can use to test and investigate further. How does it work? As I mentioned, we have a configuration file for those dev containers. And that one knows that it's built on top of the Azure Function example, which is defined in a Docker Compose file. Take a look at that. And there you can see that it just uses a Docker file. Also take a look at that in a second. And then something to simulate Azure storage locally, which is required for some of the Azure Function stuff. Now, if we take a look at the Docker file, you can see it actually is just using .NET. So behind the scenes, this is just .NET 8. And you can also see that it downloads the BC Container Helper version that we have configured, does an unzip, and moves the helper function PS1 and the get BCartifactURL PS1 into place. So those are, technically speaking, in the repository. But once I create a new dev container, or you would create a new dev container, it makes sure to grab the latest version or whatever version is configured over here from the repository to make sure that we never miss an update in BC Container Helper if it changes something relevant. You can see here 6019, that's a while ago, so it's not the very latest one, but that's because the get BCartifactURL PS1 didn't really change in that period. So we're still fine with using a bit of an older one. The other thing I wanted to show you here is that in the dev container JSON, we can also use a number of features. If you remember, we said we want to use .NET as a base image, but still we are using Azure Functions features. And that's because we have in the features defined here the Azure Function core tools. We are also using the Azure CLI for deployment. So this is also built in here. Also Docker outside of Docker and PowerShell as additional features. And we also have defined that we have a number of extensions Azure Functions extensions, the C# development kit, etc., etc. So this also means that when you set up that environment, it will come pre-configured with a number of extensions we think is helpful for you. And then the last one is just making some automated changes to the get BC artifact URL PS1 because we are not using it in a module. The export module member, for example, is commented, and something similar for the get BC artifact URL PS1, so that we can directly use it within our solution. The bottom line of this story is if you want to get up and running with the BC artifact URL-Proxy, if you want to make changes, if you want to provide some improvements through a pull request, it's quite easy with dev containers. So if you have Docker Desktop installed locally, just run the clone in container volume action, and you hopefully should be up and running immediately. If not, please provide an issue on GitHub on the repository, and I'm more than happy to try and take a look and see where it might fail. So this was basically the development side. You saw the code, you saw how you can get it up and running, and also how the development works. But of course, you also saw that there is actually a service in the cloud, and I want to show you also how that works, how it runs on Azure as an Azure function, how we use a custom Docker file, which is very similar to the one that you've seen in the dev container. At the moment, we are not using any CI/CD because we're really very rarely doing any new versions of this, because it has turned out after a bit of initial iteration that it's very, very stable. I think I only did a new release because of some new features that Arthur published previously. So I didn't have a need for that automation, but I might add that in the future. And it also automatically has App Insights, which we will take a look at in a second as well. So how does this work? Build and configuration in Azure. For that, I have a little file here to remember, and you can see here that whenever I have a new version, I will just do a Docker build with a specific version. I need to remember that I also need to update the version string in the get URL CS, as we've seen before. Then I do a Docker push. So this is actually hosted on the Docker Hub. And then I can directly go to my environment and take a look at it. So let me start a browser, and that's actually the wrong profile. And then if we go to the Azure portal, as I'm logged in, and now also this link should hopefully work. So now we have the deployment center of the function app. So if I now would have created a new image, done the Docker build and the Docker push, for example, with version 1.4.3, then I would just change it over here, save it, and then it would automatically get it and set it up. Again, this could, of course, be fully automated. I didn't have a need so far, so I didn't do it, but might change in the future. What we also see here in the function app, that this actually only contains one function, the one that we saw before, the code and also how it works. And then I can take a closer look here and see the configuration, get the URL, do the testing, etc., etc. I think that is standard Azure function stuff, not too interesting. What I also wanted to show you is the monitoring, the application insights. And I always go wrong. I should actually go to the resource directly. And there you can see that in the last hour, we didn't have any failures. Fortunately, the response time is around a couple of milliseconds. So it seems like a lot of cache requests. And then you can see here a number of requests that came in. It was available all the time. If we expand that a bit, for example, to 30 days, then you can see that we sometimes have, but very few failed requests. You can see the server time where we have the response time, where we have the peaks between 40 seconds and 1 minute, which is exactly like we've seen before locally, because sometimes it takes a bit longer to fetch the request URL. And then you can see here basically the daily peaks around 450, sometimes even up to 500. So it looks like a number of people are by now using the artifact URL-Proxy to get their artifact URLs. Okay, I think that concludes my part. I've shown you the code. I've shown you the development in the dev container and also how it's built and configured in Azure. And now I want to hand it over to Arthur, who will share how all of this works in Azure DevOps, how he built the integration with Azure DevOps.
Yeah, sounds great. Let's talk a little bit more on the Azure DevOps part. We've now seen the proxy, and maybe wondering how could we integrate that in Azure DevOps, and maybe the question of why should we integrate this in DevOps? What benefits could we bring to it? Before we dive into that, we have to touch a little bit on how we set up our pipelines in Azure DevOps at our company. We have three main stages. We have the build stage, test stage, and the publish stage. Where the last one, the publish part, is less relevant for this this part of the webinar. Most important part is the build and a little bit on the test phase. In our build stage, we have the standard things that most people will recognize on the below part, the compiling of the app, maybe signing them and creating an artifact. But we also have some custom logic on there to handle translation files to generate in the pipeline itself. For example, for Dutch Belgium, the language files. And that requires also a compile step because we have to generate the base translation file. So in that case, in our build step, we're going to compile the app twice. The first time to generate that base translation file, and the second time to compile that, including the language files of the app itself. So there are two times where we're depending a little bit also on the BC container helper we're going to see a little bit on. The test phase also the same. There also nothing spectacular. Creating a Docker image, starting a container, and publish your apps. There also is a little bit of compiling your test app if you run a test suite on there. But mostly the build part was for us the most important part. Because what we want to manage there, we want to have that running as fast as possible. The idea is if I create a pull request, then I want to respond back to the person that created the pull request. Is my build successful or not? We see in our company most times that if something fails, it's mostly the build part. That could be a dependency app that is something not compatible anymore. Or even maybe there was a warning that didn't see in VS Code. And the build pipeline, of course, noticed that. So me as developer, I want to know, is my build successful or not? The next step, mostly the test phase. Mostly we see that there are less errors there because with our test-driven development, we run those tests already during development. The likelihood of that failing in our pipelines is low. What we want to achieve is in our Azure DevOps, the build was already quite okay, like 2-3 minutes if we do a pull request. But that's just enough time to leave your seat, grab maybe get a coffee, start on the next project or something. And then if it's failed, it's quite annoying because the test phase wasn't even started. In this demo, there was only a few minutes, but it can be longer. And even if for app source, the AL validation will also have a few minutes more running before the test phase is completed. And with a company, first the build and test should be succeeded before a code reviewer jumps in and looks at the code for you. The idea was to have the build first step running as fast as possible. With the help of the BCartifactURL, we could even get the time slashed in half. And we're now minutes-ish and a few seconds more to have an app compiled, including restoring dependencies sometimes and therein. So we can quite fast have that first step up and running of our pipeline. If we look a little bit more, in our case, we want to have some agents for our Azure DevOps. We want to reuse that same image during the days. So retrieving our URL is of type sandbox, but also going to select our daily. And we noticed that can take a few minutes to get the result for the BC container helper to figure out what is the URL that I need. I'm going to minute and a half. I see some exceptions almost up to 2 minutes. before I get a URL from the BC container helper. Like I said, in our pipelines, I'm going to call this 3 times. The first compiling for the translation handling, then compiling the app, and then in the test stage again. So that's 3 times for one CI/CD run. So we're up to almost 5 minutes of resources waiting before having a result of the URL. And if I go a little further, one pull request will go into a code reviewer, and if it signs off, it will then start again. It will merge the branch we have to the master of the main branch, and then it will again do the same steps, do again a build and a test to eventually create an artifact to deploy. So every pull request is a minimum 2 times running for us a CI/CD pipeline. So I'm then up to almost 10 minutes of waiting time, wasted resources on that waiting for that URL part. Next to that, we're also for multiple projects and some customer PTs also running nightly the current builds. And every week we're also running next minor, next majors. And we see over there, if you have multiple projects, it can quite easily go up in hours. If you run like 30, 40, 50, 60 small apps in the night for a next minor, for example, it can take up quite a few moments of the pipeline waiting for retrieving the URL. So that was where we first started. And then we have a solution from a partner for Azure DevOps from ALOps. And there somebody also noticed, he created an issue and said, if I do a compilation of the app and then a few moments later again compiling the app, it takes almost as long as the initial compilation. That was the first issue we posted on there. And we figured out that most time indeed was waiting for the BC container helper to grab in and search for the right URL to return. And the idea was from there to cache that result for the first time when you do a compile, so you can reuse that same result in the next steps in your same run of the pipeline. And then I thought that is a brilliant idea. So I'm also posted there. I'm going to shamelessly take that and also implement it in our own pipelines. But then I remembered Tobias had a great artifact proxy in place. He was provided as for us for the community to use that. So also said there, maybe it's a better idea if I'm not going to cache it in the run itself, but if I use the proxy, I can cache it cross pipelines, so that not every pipeline has to wait a few minutes or something for the first run, but if the second time I need the same result, I can reuse that same cache that's maybe been before. And I started here in my screenshot also quite easily with a few lines of PowerShell to just do an HTTP call to the proxy, and then getting the result and getting then the version number of it and setting that as a variable. And then we grow it on even further and further. And I wanted to show you that in a demo, how that we currently have today in our pipelines. So if I share my screen here, you can see my Azure DevOps, and I have a new pull request and just created a small pull request with a few lines of code. There's nothing spectacular on it. I'm creating the pull request. It will search up for an agent, and then it will instantly run our CI/CD pipeline. So it's now started. A few minutes. Here it's starting our pipeline. It does a little bit steps, but here you can see getting the BC artifact URL. It was less than a second to retrieve the right URL for my pipeline. And here's also what Tobias said. I'm going to invoke the web request here, and you can see also results here coming back. So it was a cache result. I have the timestamp and also see what command was used to get that URL from the BC container helper. And then we're going to set that as a pipeline variable. Then I can reuse that in multiple stages for my pipeline to retrieve that same URL again. What we even did here is quite easy. I just create a step here again even, and you see it could quite fast, again, retrieve the same URL. So if a component that is compiling, I could always just retrieve the URL, and before compiling the extension, it can then pass it over here. I deliberately made it a failure here. If I go, if this will load here, I'm quite sure Linterkop has found something that is not okay. You have a warning here. So if I zoom up a little bit back, in this case, in 1 minute and on 20 seconds, I can return to the developer that you missed a warning. You have to change that and commit again before even starting to test phase and before the code reviewer will even look at the code. So that was the goal, to have as fast as possible the result back if the build step was successful or not. So what you saw was the Azure DevOps extension. It started quite small, with just a PowerShell script in our own pipelines. First of a proof of concept also, but then quite easy we implemented on a few projects, and then the rollout for all of our Azure DevOps projects. But then I wanted to share something to the community because I thought I had a great idea, and I thought, why not share it with other fellow Azure DevOps users out there? That's quite easy to implement without having to write your own PowerShell. Maybe there are changes quite easily can update if we found some new features or something. So there's the first start for me to create an Azure DevOps extension. It's on the marketplace for Visual Studio. You can easily search for it and install it in your Azure DevOps. There was also the link to the open source project, because this is also completely open source. I can also see some documentation on how it works and how you can quite easily implement it in your own average DevOps solution. And out of the box, it will use the URL that Tobias has shared for us with our community. But you can also set up your own URL if you like. You can dive a little bit deeper into the extension itself. Before I do that, I want to give a quick overview, because if you're first time looking into a VS Code extension, it could be a little bit confusing. And here I found a nice, great help to also start to show a little bit on the overview. The most important part is you have your manifest of the extension itself that describes the extension. Then you can have multiple modules, like here in the print screen is a build task, a release task, and a test task. There are 3 modules in that extension, and that every task has every model has its own tasks, that describes what this model can do. And inside that, you can have, for example, a PowerShell script or what you like. So this is the basic overview, and I can now let's dive into the Azure extension itself. I have here in my VS Code, I have here the extension itself. This is just the contents of general of the extension. Not much to see on here. But here we have a folder, the ArtifactURL-Proxy. There's only, as today, 1 module component in this solution. That contains, again, of a task. This describes how you can easily get that URL-Proxy. And what I mostly tended to do is work with inputs, so you can have a most generic approach on that you can change the behavior as you would like to see your own DevOps. Like I said, out of the box, if you don't specify anything, it will contact the URL of the proxy that Tobias has hosted. But if you want to create your own instance, you can also provide your own instance URL to access that one. And then some properties that are, I think, quite familiar. Again, a country, a version, select if you want to have a daily or a weekly or the latest. And all those properties we also saw on getting the URL. Also having them here so you can pass it through when doing the HTTP call. The most important part for me was, there was also something we, together with Tobias, we worked on, is to have setting on how much the cache expression should be. By default, it will only cache results from an hour and not longer than that. And for my pipelines, for us, it was quite okay to have them cache like 8 or even 16 hours. just caching through the whole day, because I didn't need, in our case, for the latest release of the latest version of the URL. The daily one was quite enough for us. It's also something you can set up here. What it will do for all those parameters, it will call a PowerShell script, where I hand over these parameters to their call on that logic in there. So if I open that PowerShell script, let me look in here. Some templating on to getting all those parameters in place. What I tend to do is also output what the parameters we received. So if there's something is wrong or something that's working as you would expect it, you can see what the parameters we received on the action were there. And I'm also doing some logic in here. For example, there's a parameter to also accept the insider URL. And we only needed that for some specific insider builds, but not for all builds. So if you somehow set it to true, but you're not requesting something that's needed to accept the insider URL, I'm going to modify the setting for you back to false. For me, most important one, also showing to you that I'm going to modify that parameter. And the main goal over there is I want to enhance the likelihood of a cache result, because calling out the proxy with that parameter set to true is another cache result than leaving that parameter outside, just aka setting it to false. So the model here is mostly tuned to get the most likelihood of a cache result, because that's the end goal we want to retrieve. Same again if you select a version and also have a daily or weekly. We're also going to adjust that a little bit on. We're also explaining here. And the most part here is I have this parameters. Going to set that into a whole parameter, and then call the PowerShell command, another PowerShell to offload to set get that to the proxy, the URL. And this is executing that here. If I open that again, receiving all the parameters. What I will do here, getting here the instance URL, assigning all those parameters, and looking for here. This is indeed eventually calling the URL, and if I'm here and retrieving here the results that I also resolve back from it. Maybe a tries or something that's wrong, also showing an exception. And I wanted to go back in here. Because what I also do is I'm having a fallback as in switching back to the basic container helper. There's also a part in here. So there's some reason proxy doesn't return a URL for me. I will switch back to the BC container helper and install the module, and then we'll call just the BC artifact URL again. So I will then have a URL as a fallback of the BC container helper itself. So that if the URL somehow fails, I would like my pipeline not to fail. It will take a few minutes longer, but that's okay for me. And if that all fails, I'm also going to show, of course, an error again. And that's the part here a bit on. So that's what's going behind the scenes of the Azure DevOps extension. Some takeaway or learnings for me. Personally, for me, it was my first Azure DevOps extension I created, and for me, it was a little bit steep of a learning curve to get started. But also, I think it's a great idea to get some insights on that, because then you also understand if you have other extensions, what issues they may have or what challenges they have to overcome. And one of them was, for example, on the PowerShell running. The PowerShell scripts I have are fine with the PowerShell 3 handler that will execute PowerShell 5.1 if I'm not mistaken. Upgrading to a newer PowerShell version like PowerShell 7 is now quite common. That's not something easy for me to do in an Azure DevOps extension as of today. So it was quite helpful to see that other partners also, our extension also sometimes looking to get to there, and that's quite not as easy as I would expect it. And also for me, automated testing isn't also there in place today. The PowerShell scripts I can execute and test manually standalone. But I'm also looking in the future to see if I could implement some automated testing on this extension to also gain some learning on how that could be handled for an Azure DevOps extension. So that's for my part on the Azure DevOps extension. And I think we're then also at the end of our session so far. Together with Tobias, wanted to thank you for joining us today. I'm also wondering if there are questions, or which questions we could answer for you.
Yes, and thank you from my side as well.
Well, thanks a lot, Arthur and Tobias. I see no questions in the chat, but I have several questions. When looking at the presentation, and a really great presentation it was, especially on the public cache. How long is the cache will be there?
Very good question. I forgot to mention that. So by default, it's 1 hour. You saw the expiration parameter, and you can set it as short as 15 minutes. But after 1 hour, it definitely will expire. So if you do the same call after 1 hour and 1 minute, then you will get a new result in any case. If you need something shorter, you can shorten it down to 15 minutes.
Okay, perfectly. And you said you can implement it by yourself, or use the community URL. What's the benefits of doing it by yourself? Because there's already a great proxy out there. So why want you use not that one or build it yourself?
I mean, maybe Arthur, you can add further ideas or further reasons that you can think of. But from my point of view, I can only see two. One would be you don't want anyone to know which versions you are using. I think that's a bit far-fetched, but I don't know. I know there are some really paranoid companies out there. The other one would be you make an investment into your pipelines by relying on the artifact URL-Proxy, and you might be worried that if you rely on the artifact URL-Proxy, it might go away, I might stop hosting it, or whatever might happen. And then I think it's good to know that in that case, you can also easily host your own instance. So it's more like a fallback if you're wondering whether it makes sense to have an additional dependency on this solution.
Yeah, that's what I completely would agree on. That's also what we had internally a discussion on, because it's out of our control that it's hosted there, and our pipelines are now depending on it. So also for us, it was something if some for reason Tobias would never stop hosting it, or for some reason, we have an option to host it ourselves. So that was more the idea of it.
Yeah.
But to full transparency, we're not hosting it ourselves, but as if they're using the public URL.
Yeah, because if you're using that public URL, probably the first time, probably if somebody has already got that URL, and your time is faster then.
Indeed. Yeah.
And my last question is, because this is really great, and Arthur, what you mentioned is, well, I thought almost 50% it is cut down. But how long will it take to implement this in your pipelines? Getting that from the proxy, the URL.
It's a very valid question indeed. It kind of depends on the structure of your pipelines, I guess. For me, the most easy part was I built it as an additional block, so you can add it as a step in between. And that step will then create for you a variable that you can pick up in a step later on. I think most solutions also support that. I know the BC container helper itself also support that you can pass in the URL as a parameter, as an input param, to the function. So most ideal scenario is that if you have a pipeline there, you set this block just before the action for the BC container helper, or maybe using another solution out there. You can then place the step just before that action, and then the result of that parameter of that action, pass it to the next step, and then you're good to go. So it should be quite easy, I think in half an hour, maybe. and you're up and running.
And if you even want to take it one step further, even faster, I mean, what Arthur showed you, if you do it in a dedicated step, then you have the additional benefit that you can take a look at the response headers and analyze what you got, etc. But also you could, instead of grabbing it and then using it later, you could also use the URL to the BCartifactURL-Proxy directly in the place where you would previously have used the original URL. So if you don't set the do not redirect parameter, then you will, by calling the artifact URL proxy, directly get the artifact. So you could even use it directly. Then you lose the additional benefit that you can inspect the headers, or at least not easily. But that could be the simplest implementation in your pipeline, that you just replace what you're currently doing with fetching the URL directly from the proxy.
Yeah. Yeah, and so you said that it is quite easy to do. So why not? Because yeah, your pipelines will, in this case, what the example from Arthur was showing, it was cut in half for it.
Yeah, fully agreed.
Well, thanks a lot for organizing this and presenting this for us. It was very useful, and what I said, the waiting time is much slow. So sorry for that extra cup of coffee for it. Thanks a lot, Arthur and Tobias, for this, and also thanks for the on the Aropia webinar team for it. Also, thank you for listening to this webinar. What I said previously, the webinar is recorded and will be presented on YouTube later today or tomorrow. And here we have got also the URLs if you want the YouTube, the newsletter if you want to subscribe for upcoming sessions. And if you want have any questions or have any suggestions, or you want to present yourself a webinar, you can email us on the webinars at areopa.academy. Thanks for it, and have a really great day.
Thanks for hosting, Bert.
Thank you.